More than a lot of other science classes, chemistry really focuses on precision and rounding. And as a result, we focus on what we call significant digits or significant figures. When we are in the lab and making measurements, we are the one who is trying to make it correctly. When we make a measurement, if we place it on a balance, the tool does it for us. But anytime we're measuring a volume, anytime we're measuring a length, anytime we're using some sort of tool that we are measuring, we always look at what values we have. Like here, we're between 35 and 40, but more specifically, we're a little bit higher than 36. But even more specifically than that, we would estimate one digit that we're between 36 and 37, around 36.6. All of those numbers that we record, the certain digits, it's definitely between 36 and 37, and it's estimated as a little bit more than halfway are the significant figures. All digits that you read in a measurement are significant digits unless it's just a placeholding zero. Significant digits tell us how certain and how precisely a measurement was made. When we make it ourselves, we know that. But when we read a number from somebody else, or when we start to do calculations with our number, we want to communicate that certainty. That's why significant figures are important. We've got the rules right here. And first and foremost, everything that's not a zero is significant. Zeros are significant if they tell us how precise the measurement was made. So some phrases right here tell us this, but zeros at the end of the number when there's a decimal are significant, but zeros at the beginning that are just placeholding values, basically telling us how small our value is, or zeros at the end if there's not a decimal, just telling us how big our value is, are there to tell us how big or small, but not about the precision of the measurement. So we'll practice and apply this, but the great thing with AP chemistry is there's usually a little bit of wiggle room when you're looking at those things. If we're making a measurement, we nail it right on the head. But when we're doing some calculations or rounding to a final answer, as we'll see right down here, we've got that little bit of wiggle room. But if there's an exact number, like there's 12 eggs in a dozen, or if we're counting how many items are there, we remember that those aren't rounded, those aren't estimated, those are exact numbers with what we would represent as an infinite number of significant figures. So when we're doing significant figures in calculations, we round based on how many digits we have from the values that have been given to us. Most of what we'll be doing is multiplying and dividing. When we do that, we look at the digits or the numbers we're given, whichever one has the fewest digits, or specifically the fewest significant digits, we round our answer to have that same number of digits. As we work through all the problems, I'll just naturally do that, but I'll try to bring that up and bring that to our attention. When we're adding or subtracting, the rule is slightly different. It's not about how many total digits, it's about how many decimal places we can go to. For that, you go to the thing with the fewest decimal places, and we'll see that. And as we do both of these, the key is that we will apply it in the lab, and that's how we'll really do it. If we have a long calculation, which we will at times, we keep all of the numbers in our answer in our calculator as we go, and we only round at the end. And then there are different rules if we're not doing just multiplying, dividing, adding, or subtracting. When we get logs and exponents, they have their own set of special rules. The nice thing with significant figures is we try to introduce, teach, and even practice this in first year chemistry. And sometimes you might gain or lose points for that. In AP chemistry, on the AP exam, almost always there's only very few points related to this. It's more about, do you understand the idea of precision? And as a shortcut, if you round every single or any answer you have to 3 digits, you're probably going to be pretty close more often than not, because we don't have too many measurements that have 4, 5, 6, 7 significant figures, and we have very few that only have 1 or 2. So if you're kind of stuck and not sure what to do, we're going to round it to 3, and we're going to call that good enough. But when we're in the lab, when we're making measurements, it's going to be a big focus. because a big part of chemistry and its application is analytical chemistry. It is getting the precision right so our results can be as good as possible.